11, 18.
Mr. Kimmy,
Sure.
I'd rather do this last one. Because I was looking at it, and this looked, I did this, I didn't know it was just transparent.
Remember,
That's all.
if you're going to shade, it's a solution, which means at that point makes the inequality what?
So equal to or greater than?
Just true.
0. It's true?
If it's a solution, it makes the equation true, right?
Yeah.
For the inequality. You didn't check to see if it does that. You have not checked to see if those points make those inequalities true. Do your homework.
Okay, well, I know that they can both be equal to or greater than.
It does not always work that way. You need to check your points. Then you gotta do your homework. You know that. You weren't here. Huh? Some good ideas. A couple things I do want you to pay attention to, but those are all pretty good, Desiree. Okay.
Oh, quadratics is getting a lot easier, actually.
Good.
Do we need to turn this in as well? No, because we're not done with this. But I did do it.
Get through that one. All right. Let's go ahead and get started with today.
Is there any materials we need out?
Yes, literally on the board. I've already told you 6.1. I would recommend also having out Gold Rush because it'll help you. Chris, did you forget to put your phone up? Julia, did you have a phone?
No,
Huh?
yes, yes.
Julia, number 13. You don't need to move it, but Chris, just for the future, you're number 3. All right.
I need my paper for a second.
Huh?
Give me 1 second. Are you supposed to turn that paper in?
No.
Shall we turn mine in when you're done?
You just said no.
You just said no.
Do
It
you
says
listen?
turn it in, he was being sarcastic.
No, I'm not being sarcastic.
Oh. Then what does it say turn in? Oh wait, what?
That systems homework that we had last week, it was said March 22nd, it's neither of those.
Oh.
All right, I think you already turned yours in.
Oh, okay, okay.
What did I do? I was way back there now. All right. Well, that just looks ugly.
Wow.
How did that? I had it in my hands.
Penny, that was a fantastic trip.
Hey, it's bouncy. I want to hear it.
It's bouncy.
I'm a runner for a reason.
All I hear are excuses.
Well, so how fast can you run a mile then?
I don't know. I did.
Mine takes 12 minutes.
Dang, bro. I know for sure I could do sub 8, but I've been training for distance. Like I did the half marathon this weekend.
Wow.
Okay, how would you run that in?
A little over 2 hours. 2:03.
Guess what? We won the West Alabama University tournament.
Good.
I'm proud of you.
Okay. Really quick note on the 6.1 Go, because you will have some more homework with it tonight. It asks you to identify the what for each of those functions. Peyton, you can work on that during enrichment. I need you to focus
I'm
on
not looking at
The
that.
Okay.
rate of change.
the average rate of change, right? Which each of those functions is a what kind of function?
Quadratic.
It helps to go look at 6.1 Go to identify what type of functions they are. They're what? They're linear. Good.
Yeah,
That's it.
I was going to say
How do we know that they're all linear?
Because they have a rate of change.
They have additive rates of change, right? So if they're linear, they have additive rates of change. And this is an important detail. Some of us did show the work for this, but I didn't see a lot of us who correctly noted one really important detail. What do we call the additive rate of change?
The slope.
What?
The slope.
Oh.
The additive rate of change is called the slope. And Layla, I saw you very correctly write rise divided by run, but I want to make sure, and you might have put it on other ones, I just know on one, you just put rise divided by run, right? So m is equal to rise divided by run, the slope. So you should never just put, hey, 4. Because what do you mean by 4? If you were to put, hey, m equals 4, I know you're talking about the slope. In order to properly identify that rate of change, I need you to put m equals.
Okay.
9.23.
What?
Your consistent miles for a half marathon. It's
Yes.
13 miles, right?
Yes.
So you'd have a 9.23.
Yes. I was a little bit slower than that, but yeah.
That's just consistent if you would have kept it. Give or take a piece.
Okay, so my slope is my rise divided by run. Slope is 4 on one of those. All right, let's move forward from there. Make sure you put m equals for the slope. That does remind me as a quick note, later today on the task or on the practice problems, it's going to ask you to write both recursive and explicit equations. Recursively, how does a recursive equation always start?
There's a big,
F
something like
of
that,
X is
or
equal
like the
to-
E in the,
F of x is
There's
equal
like
to.
X and then there's like an E and something.
What?
And-
E.
X
There is
star
never
or
an
something?
E whatsoever.
It looks like an E.
That's current minus speed.
And then
You're
R.
thinking about set notation, I believe,
Oh, okay, no.
for solutions. The recursive though is f of x equals f of x minus 1 or f of n equals f of n minus 1 because f of x is my current output, f of x minus 1 is my previous output, and then I started using this notation, a little star there, star rate of change, because we've started to realize that there's multiple different types of rate of change. There's constant additive, there's multiplicative, there's now linear rates of change. So recursively, we need to put that rate of change. There's one more detail there, but also we have explicit equations is the other one we're looking at today. Just name a few explicit equations we've learned this year.
One plus two.
It's been a minute since we've used that term, but so this is important to notice.
What do you mean if you like point slope?
Point slope is an explicit equation. There's just two different versions of it. That's one explicit.
That one.
Standard is actually another explicit.
Standard's explicit?
Yep.
Point slope in
Huh? Standard would be
why-
recursive.
Standard would not be recursive. Standard is not f of x equals f of x minus 1.
A of x plus by equals c, right?
Not a of x, ax plus by equals c.
Oh.
When we say explicit, and it has that note over there on the board, explicit just means we're relating inputs and outputs, which usually is y equals mx plus b, but in general it's just an x and a y, an input and an output. It's recursive when it's current and previous. So when it starts talking about explicit equations later, we need to think about those equations that have inputs x and outputs y.
I'm gonna be honest.
How'd you
I always
reach all the
suck
way
at
up
these,
there?
so.
That's why we need to work on it and get better. It doesn't matter what you've done in the past. It's about the growth you're going to make in the future.
You know how many tutoring sessions I had to come to actually learn the explicit and recursive?
Say again?
I was horrible at explicit and recursive.
Yeah, in the past, we're growing and getting better at them.
How'd you reach all the way up there?
I had this really cool ability where I just like stretch my legs. It was kind of like,
That's what I said, he's too short.
thanks guys,
You on a ladder or a chair?
I use the desk.
Oh.
Today's agenda, we're going to look at the objectives. We're going to do a quick quadratics recap, especially for those of us who were gone on Friday. This will help a lot. I'm also going to make sure I upload the video from Friday this afternoon on YouTube and Schoology so you can check it out.
Sure.
I know you probably won't, but it's there if you want it. I would recommend it because I will say what we wrapped up on Friday is actually the foundations of everything this unit is on, so it's really important you look at it. But 6.1 set and go sections is what we'll focus on today. We will not get to 6.2 until tomorrow. Alright, does anyone remember what I mean by SMP, and no, I do not mean simp?
Standards for mathematical practice.
Standards for mathematical practice. This
Oh, why do you have a 3 and a 7? What the heck?
is the third SMP, the seventh SMP, the eighth SMP. There's a total of 8 of them.
Where's the 1 and the 4 and the 5?
So remember, I'm only putting the 2 or 3 that we're really focusing on today up there. So I'm not going to put them all of them every single time. I'm going to pick 2 to 3 that we're focusing on. So in order to learn these content standards, right, these content objectives, we're going to try to do these things, these standards for mathematical practice. Learning how to do these things, honestly, is what's going to make you a better mathematician, and I'll even go as far to say as a good mathematician. No good mathematician knows all the math that ever existed. It's just not possible. But these are the things that mathematicians do to learn math better. Right? So we need to be able to construct viable arguments and critique the reasoning of others. A viable argument, just, hey, here's a thing that I believe, and here's evidence why. Not just saying I believe this thing, it's this is what I'm thinking and this is why this is true. And then critiquing the reasoning of others, just meaning, hey, I've thought through what you said, and have you thought about it this way, or have you considered this idea? And notice I'm not being rude or putting someone down. I am asking questions to help us come to a better understanding because, well, I thought there might be something else going on there. Look for and make use of structure. Math is all about patterns, and so we need to find those patterns, make sense out of those patterns for the future, and then look for and express regularity and repeated reasoning. When you are repeatedly doing something over and over and over again, you're going to better understand it, and so we need to be trying to express regularity in our reasoning. All right, all to learn these 3 content objectives. Desiree, can you read our first objective?
Identify linear, quadratic, and exponential functions.
All right, we want to be able to identify those linear, those quadratic, and those exponential functions because there are distinct things that separate each of them, which we're going to recap that a little bit. Shelby, can you read our second objective?
Write recursive and explicit equations for the above functions.
All right, so remember we recapped what it means to be recursive versus explicit over here. Use this as a guide for linear, quadratic, and exponential. And then Layla, can you read our final objective?
Determine the rate of change in linear equations.
Well, linear relationships. And I only bring that up because it's not just equations that we're looking at, right? You can find the rate of change in tables and in graphs and all those other things, right? So we want to keep that in mind? Cool. All right, recap, quadratics. Corel, pick one of these 3. Tell me one thing that was special about a quadratic, either graphically, tabularly, or algebraically. Something that was different from linear and exponential. You can also use your notes. Or if you remember something off the top of your head, go for it. But guys, y'all don't have to ignore your notes.
Quadratic function has the highest power as the second power.
Okay, which representation does that show up in?
Is it algebraically?
There you go, algebraically, specifically the explicit equations. Highest power is the second power, right?
Yeah.
When we looked at the equation last week, I think it was y equals, was it negative x squared plus 50x? Was that the right equation?
Yeah.
Yes, that was the correct gold rush. Okay. Notice how the highest power is that second power. Even if it's something as simple as y equals x squared, does that have a highest power of 2?
Yeah.
So is that quadratic?
Yeah.
Okay. Notice this has a relationship between inputs and outputs, right? Independent and dependent variables. So that is what type of model? Recursive or explicit? Inputs and outputs.
I forgot, but I think it's recursive. I don't know.
Notes are on the blackboard. There's also an example of recursive on the whiteboard.
Explicit model. Oh, it's explicit.
It's explicit, it relates to inputs and,
Outputs.
remember Corel, recursive is always f of x equals f of x minus 1, current and previous, right? Okay, So, highest power is the second power. Layla, tell us one other thing that was unique about quadratics, either graphically or tabularly.
Is shaped like a cave down.
Okay, so there is a concave down. Does anyone remember what the name of this shape is, though? Parabola, right? It's a concave down parabola, right? If you remember, it kind of looks like a frown, so it's concave down like a...
Rainbow.
I mean, it is concave down like a rainbow. It's not going to help you remember down like a frown, though, or down.
Oh,
You can say it whatever you want. It's just the mnemonic device that I've heard or used in the past is concave down like a frown. This parabola is concave up. Do you remember what it was like?
Like a cup.
Like a cup. So we have those parabolas. We do have a, what is this point called?
The maximum.
minimum, maximum.
Which one's which, though?
That's the
Minimum.
Maximum,
Minimum.
minimum. Okay, but it is most important to really look at it tabularly. What was unique tabularly about a quadratic?
The rate of change, you can have two sets of rate of changes.
Two sets of
I don't know the word you use.
Difference.
difference. Second difference, and,
Right.
Hey, Miss Channing,
sir,
off subject, but it's an idea that I...
then I will address it when we break into small groups in a second.
Okay.
Hey, Skin.
Sir,
You supposed to say these like notes or not?
huh?
You supposed to say these are notes or not?
They should be on the Gold Rush task under your notes. These are the most important ideas that we talked about. So I want to remind you, the second set of differences tabularly was a constant what?
It's the same number.
Constant what, though?
Right.
What are we constantly doing?
Right.
They're constantly
Okay.
subtracting.
Sometimes, so,
Adding.
right, constant additive. Because remember, you can add a negative, right? So it's a constant
True.
additive rate of change. Or the
Yeah.
second difference is a constant additive. Because what type of function has a constant additive rate of change? Say again?
Linear one.
Linear, right? So if the second difference was constant additive, the first difference was linear.
Oh, I mean, yeah.
And remember, the first difference is my rate of change. So that quadratic function had what type of rate of change?
Linear.
Linear. Okay? That recap helped bring back some memories,
Yeah.
hopefully. Chris? Did that help?
Yeah.
Yeah? Where did I leave my remote? Yo, mine is a terrible thing to waste. I feel like I'm constantly losing my mind. Oh well, I'll just click on the laptop until I find that remote later. Okay, so this is where we picked up, or where we left off. I don't want to know, where is it? Dang, it is right there. That's embarrassing, y'all. It's more embarrassing than dropping the sponge when I try to catch it.
Yeah.
And then you bring it back up.
Okay,
Oh.
because I'm funny and it's a joke and people laughed.
No,
Alright, what type of function did we have here in 8a?
exponential.
Why was it
Eight prime.
exponential?
Because it's yeah, repeating what's wrong.
Repeatedly what?
That's wrong.
Multiplying, right? So it was a multiplicative rate of change, so it's exponential. 8b was
It
Quadratic.
was.
quadratic. Why?
Linear rate of change.
A linear rate of
Not
change.
function, but rate of change.
And then 8c was
Linear.
Linear?
function, because it has a
Repeat added.
additive.
additive rate of change, or repeatedly adding, right? So those are all important things to remember. I'll write those notes up on the board while y'all in your small groups go ahead and get to work talking with each other, trying to write those recursive and explicit equations. I know it's been a minute, but that's why we need to practice and get better. It's not about what you've done in the past, it's what you're going to do in the future. That growth mindset, constantly improving. All right, let's get to work.
Hey, we got now about every person is supposed to. I forgot.
Me too.
What'd you say?
Nothing.